All right, guys, today we are talking about limits. And right here we have a formal definition of a limit. But before we get into the formal definition of a limit, what a limit is really the height that your function is trying to reach. So the informal definition is the height that your function is trying to reach. Or in other words, it's the y value that your function is trying to get to. So if I look at this quadratic function down here, if I'm looking at just the general limit of the function, as my function goes to the right, it's getting higher and higher and higher. It's trying to go up to infinity. As my function goes to the left, it's trying to go to infinity. But we're not usually concerned with the limit of the entire function. Sometimes we're looking at just the limit at a certain point. So for example, if I look at exactly the point 0, if I'm considering the height that my function is trying to get to, as I come from over here, my height is getting closer and closer and closer to 0. And coming from this side, my height is getting closer and closer to 0. Now, one thing to be mindful of is it doesn't matter what this point actually is. It just matters what it's trying to get close to. So the formal definition is as we get really close to that x value. So as I get really close to 0, then the limit of f of x as x approaches 0 would be my y value right there. So this one, my limit would be 0 because I'm trying to get to 0. And the way that we write that is the limit as x approaches some number is the y value. So the limit as x approaches this number is going to be my y value of that function. And if you notice, there's two equations here. One of them has a minus and one of them has a plus. And that's because this one is when I look at that function coming from the left, and this one is when I look at the function coming from the right. So again, the way that this would be written is the limit as x is getting close to 0 from the left of my function's called x squared. And that would equal 0 because I'm getting really close to 0. And I want to know as I come from the right-hand side, my function is also trying to get really close to 0. Now, if both of those are true, if those are both trying to get to the same number, then we say that the limit of the function at that value is that number, is 0. So I can say, because both of these are the same, I can say that my limit as x gets close to 0 of my x squared function, my limit, my y value gets close to 0. Now, I don't care what happens right at x equals 0. I only care about what happens as we get close to 0. So we only look at the left and the right of our c value. We're not as interested in the c value itself. We're only interested in the left and the right. So for example, look at this function. The limit as x gets closer to 5 of my function, -2. This is a piecewise function. So what it looks like is if x is equal to 5, then my y value is going to be -2. Otherwise, if x is any other number, my value is going to be 4. So when x is equal to 5, my y value is -2. So there's x is 5, y is -2. But all of my other x's, my y value is actually 4. So everywhere else, my y value is up here. So what happens is my function is a piecewise function. It looks like this. But as I get close to that 5 number, I've got a hole in my function because as soon as I hit 5, my value changes to -2. So when I look at the limit, if I look at the limit as x approaches 5 from the left of f of x, then coming from the left-hand side, as I come from the left, I'm getting closer and closer. My y value is not going up or down. I'm still getting closer and closer to this y value. I'm still getting closer and closer to 4. But once I hit 5, it changes. But I don't care about that. I just care about what happens as I get closer. And similarly, my limit as x approaches 5 from the right-hand side of my function, as I'm coming from the right, my y value is 4, 4, 4, 4. It stays 4 all the way up until I'm arbitrarily close to x being 5. So my limit is still 4. So my left and my right limit are both 4. So I can say that the limit of this function as x approaches 5, my limit of f of x is equal to 4. Even though my value at 5 isn't 4, my limit, I'm still getting closer and closer and closer to 4. Those two numbers don't have to match. Okay, so let's look at some examples. This first one, I'm looking at, this has been graphed on the calculator, and here's my function right here, x cubed minus 8 divided by x minus 2. Now, if you notice, there's this hole right here when x is equal to 2. I've got this gap right here. So I'm not interested in what is happening at exactly 2. I'm just looking at what's happening near 2. Okay, so if I were to say, as I'm coming from the left here, and as I'm approaching that x value of 2, I'm getting closer and closer to what y value? This gets me at what, about 12 maybe? So I'm getting really, really close to 12. So I could say that my limit as x is getting closer to 2 from the left, the limit of my function f of x is equal to, I'm getting closer and closer to 12. And then if I look at it from the right, as I'm coming from the right and moving down, I'm getting closer and closer to that same y value. So my limit as x approaches 2 from the right of my function is still 12, which means since these are both the same from the left and the right, my limit as x approaches 2 of f of x, my limit is 12. Even though at that point it doesn't equal 12, that's what I'm getting closer and closer to. Okay, so this little hole in it makes it what we call discontinuous. And what that means is I can't draw this without picking up my pencil, because as I'm drawing that parabola, at that point, I have to pick up my pencil and leave a gap. And we call that being discontinuous. Okay? So applying this to a couple of different problems. Okay, so we're looking at, it wants us to find the limit as x approaches 2 of this function, and it doesn't give us a function, it just gives us a graph of a function, which is great. Whenever it gives me a graph of a function to find the limit, that's really easy to do. I don't have to do math at all, I just look at the picture. But it also wants me to find what is f of 2. And all that means is plug in x, or at x, what is y, since we can't plug it in. Okay, so for this first one, as x approaches 2, now remember, I've got to approach it from the left and the right. So as I'm coming from the left, as I'm approaching 2, my y value is -1 all the way across. Now, once I hit 2, it changes, but I don't care about when I hit 2. I just want to know what happens as I get close to 2. So as I'm getting closer to 2, my y value is -1. Now, if I'm coming from the right-hand side, as I get closer to 2, I'm getting closer and closer and closer. My y value is getting closer to right here, to 1. Now, From the left, I get close to -1. From the right, I'm getting closer to 1. So my limits aren't the same. So what we're going to say is that the limit does not exist. LDNE. Or you can write it out. Limit does not exist. Okay. Make sure you don't combine the does and the not. If you combine that to limit doesn't exist when you abbreviate, you get LDE, which looks like limit does exist. So be really careful. Either write limit does not exist or limit does not exist. Don't abbreviate there. But it also wants to know at f of 2, what happens. So when x is 2, my y value has a value of 1. So f of 2 is equal to 1, which has nothing to do with my limit. It just wants to know what that value was. Okay. So for this second one, same thing. It wants me to find the limit as x approaches 2 from the left of my function. Again, I don't know what my function is, but as I approach from the left, I'm coming from the left and I'm getting closer and closer and closer to this value right here, which is -2. See, we like ones that we can use a graph. The picture is really easy to see. Now coming from the right, the limit as x approaches 2 from the right-hand side of f of x is equal to, as I come from the right, I'm getting closer and closer and closer to this y value, which is +2. Now, since these two approach different numbers, then I say that the limit as x approaches 2 of f of x, that limit does not exist because I approach different numbers. Now, at f of 2, if I look at x equals 2, my value, it's not either one of these limits. My value is 0. And I don't care if my limit and my value are the same. They don't have to be. They can be completely different numbers. All right. So going on to a couple more. This time it wants us to find the limit as x approaches -1. And then it wants us to find f of -1. So from my limit, x approaching -1 from the left. So from the left, I'm getting closer and closer. As x gets close to -1, my y value gets really close to +2. Now from the right-hand side, my limit, as I get closer to -1, my y value gets closer to 2. So since these approach the same value, I can say that my limit is 2 of the whole function. That limit as I approach -1, that limit is 2. Even though f of -1, there's just a hole right there. That doesn't even exist. There's no value at this point. It's a hole in the graph. So I can say that that point doesn't exist, but even though it does not exist, I still have a limit at that point. We still approach y equals 2. Okay. Now this one on the right is my limit of x approaches -1 from the left of f of x. And if you notice, I'm writing it out all the way, every step. That's something you're going to want to get used to for the AP test. You cannot take shortcuts when you're writing out these limits. You got to make sure to include all the parts, or you could get it wrong on the test. So as I'm coming from the left-hand side, and I'm approaching -1. Now, -1 is right here. I'm going to mark it. So as I'm approaching -1, I'm approaching 3, my y value. Now, from the right-hand side, as I approach -1 from the right-hand side of f of x, as I approach it from this side, I'm also getting closer to 3. And since they approach the same value, my limit does exist as I approach -1. And it's 3 because those are the same value. And then if I wanted to find f of -1, that exists as well. My y value when x is -1 is just 3 also. So this one, all 4 of those happen to be the same. Okay, couple more. Infinite limits. This is something that we want to be careful of. If I look at the graph on the left, it tells me for both of these problems, as x approaches 0, what's my limit? So my limit as x approaches 0 from the left of my function. Again, I don't know what my function is. I just have the picture. But from the left-hand side, as I follow my function, all of a sudden I start climbing really, really high. So I would say that as I get closer and closer to 0, I'm getting higher and higher and higher. And we are going to say that we are approaching infinity. And from the right-hand side, as x approaches 0 from the right of f of x, as I'm coming from the right-hand side, I'm moving to the left, but then all of a sudden I drop down really sharply. And I'm going to keep dropping down further and further and further as I get closer to 0. So I'm going to say that I approach negative infinity. Now, this raises quite a few problems. First of all, they're not the same. This one is an infinity. This one is a negative infinity. So for that reason alone, I can say that the limit as x approaches 0, since they're different values, that limit does not exist. But this infinity and this negative infinity, those are not specific numbers. And if you remember the definition, it said that we had to approach a specific number, a unique number. But infinity is not unique. So technically, I could say that this limit does not exist, and I could say that this limit does not exist, because infinity and negative infinity aren't specific numbers. Now, on the AP test, it will accept either of these answers coming from the left and the right. If you put infinity, because some books accept that as an answer, or if you put limit does not exist, you'll get that one correct. However, you cannot put that the limit approaches, if they're the same, you can't say that this one approaches infinity. You'll get that one wrong. Okay? So since infinity is not unique, the limit does not exist. Okay? Now, if I wanted to find f of 0 on this one, my x value my y value when x is 0, f of 0 is right here. My y value is 0, which again doesn't bear an effect on our limit. It's just information we may want to know. Okay. Now looking at this other example, my limit as x approaches 0 from the left of f of x. If you're not sick of writing that yet, you're going to be soon, but it's important that you write it out every time. So as I'm coming from the left, clearly I'm getting higher, higher, higher. I'm going extremely higher as I get closer to 0. So I'm approaching infinity. And from the right-hand side, my limit as x approaches 0 from the right, I'm also going up, which becomes infinity. So can you say that the limit as x approaches 0 of f of x equals infinity? They are the same. So this theoretically is correct based on some books. So in this case, the AP test would say, yes, these are all true. But I would say that the limit does not exist. And again, the AP test accepts both of those because some books teach it one way, some books teach it the other. I think it's safer to say that it does not exist, not that it approaches infinity. But I'm going to accept either one of those answers, and so will the AP test. Okay? Now, f of 0 at 0, this is called an asymptote because these numbers are getting closer and closer and closer to 0, but I'm never going to actually touch 0. So f of 0 does not exist. There is no y value that these two are going to reach, at least based on the information that we have. We can't see that that's ever going to happen. Okay. So a couple of things, common behaviors associated with a limit not existing, because limits exist in a lot of instances, but we found some along the way here where the limit did not exist. And so those common behaviors to watch out for. The first one is if either part of the graph, the left or the right, is heading towards infinity, positive or negative infinity. If the graph is heading towards positive or negative infinity, then the limit does not exist. Okay? The second thing to watch out for is if the left and right limits don't exist. Or excuse me, if the left and right limits are not the same. I'm getting ahead of myself. If the left and the right limits are not the same, then we can say that the limit does not exist. A left limit and a right limit exist, but a limit doesn't exist that has both. And the third thing that we need to watch out for, and we haven't seen an example of this yet, we'll see a few of these when we get into more trig functions. But if the function is oscillating between the same y values, or in other words, if this was my graph, and if this was 1 and this was -1, and if my function kept going up to 1, down to -1, up to 1, down to -1, if it kept following that pattern, then my limit does not exist. And we'll see some examples of that later. But be careful. As long as that goes up and down between the same y values, then the limit does not exist.